Hi there. In this video, we'll take a look at two intersecting lines and see what relationships will come from that. So when two lines intersect, they do form four angles, two little angles and two big angles. And if you study the figure for a moment, evidently the two little angles are the same size and the two big angles are the same size. So the purpose of this video is to do two things. We'll demonstrate that idea visually, and then we'll demonstrate it logically. We'll come up with a proof. So here goes. First thing we'll do is just draw a circle around the point where the two lines intersect. And that circle intersects the two lines in 4 points, which I've labeled A, B, C, and D. All right, so let's be sure that these two angles, labeled alpha and beta, really are the same size. All right, you can see from that demonstration that the angle where alpha started ended up where beta was, and the angle labeled beta ended up where alpha was. In other words, we mapped one onto the other, and we did that by means of a 180-degree rotation. And you can see that the entire figure ends up right back where it started. In other words, the figure is symmetric under that rotation. So a couple things come away from this demonstration. Number one, two intersecting lines do have 180-degree rotational symmetry. And number two, which is more to the point, the vertical angles that share a vertex right here are congruent by that rotation. All right, so now let's turn our attention to a proof that these angles are congruent under that rotation. In other words, does everything sort of behave as we would expect it to? All right, so what we'll do here is just focus our attention on one line at a time. And in this part of the demo, we'll look at line AC, and we'll just track what happens when we rotate A 180 degrees around point O. Now keep in mind that a 180-degree angle is a straight angle. And so if we perform a 180 rotation of a point around another point, we should end up on essentially a diameter of that circle, right along a straight line. So here goes. Okay, as you can see, A ended up specifically at point C, and we know that had to be the case because A, O, and C are collinear points. They're all coming off of this line right here. And so we know that A has to land at a spot that's on that line somewhere, and in particular, it was just where that line was hitting the circle. All right, so if we let the symbol F represent this transformation, this 180 rotation, then we have that F maps A onto C. And what I'm doing here is I'm just keeping track of these three important points, the vertex of the angle, and then one point on this ray and one point on this ray. And if we can see where F takes each of these three critical points, then we'll be able to prove that the angles are indeed congruent. All right, so F maps A to C. What does it do to point B? So this time we're going to watch the 180 rotation act on this line, and we'll follow point B through its path along the circle. Okay, as you can see, the rotation maps B onto D. And again, the same kind of reasoning is at play. B, O, and D are lying on a straight line. They all live on this line right here. And so the image of B should be a point on that circle that's also on this line, and that can only be D. So in conclusion, F maps B onto D. All right, so we've looked at a point on this ray, this component of the angle, and we've looked at a point on the other ray, the other component of the angle. Let's look at the vertex of the angle and see what goes on with that. As you see here, when we perform a rotation around point O, every point on the circle moves. In fact, the whole plane is moving, except for point O. Point O actually stays right in place. It's a fixed point. So we have that the transformation F fixes O. It maps O to itself. All right, summing up. We saw here that F maps A to C, O to O, and B to D, and therefore angle AOB does indeed map onto angle COD. So the image of angle AOB under F is angle COD. In other words, we can map alpha to beta, and so this pair of vertical angles are indeed congruent. And this proof goes to show that any pair of vertical angles are congruent. Thanks for watching.